So at the top of page 238, it talks about in that box, you see that the domain and range of a function and its inverse, it talks about them switching. We already talked about that in that last example. And example 2 here says, determine an equation of the inverse. Sometimes you can see in a question I'm just going to write down, I'm noticing that it doesn't say function. I'm not really happy with how the pen of the smartboard like erases previous things that I wrote as I write this here. I don't know if you've noticed that. Sometimes I write something else in the white part. I don't know. Anyways, so I just want you to notice that this doesn't say function because just like the last example that we did, it didn't say graph its inverse because when we graphed its inverse, it wasn't a function. So on this one, determine the equation of the inverse. So this is an algebraic thing. We want an equation. We find the inverse by switching x and y everywhere. So in an equation, you can find an inverse by switching x and y. And typically, they then say, once you've switched x and y, could you get the y by itself? So if I wanted to get the y by itself, I could do x minus 4 equals negative y squared. I can multiply everything by a negative to get the y squared by itself. And then to get y by itself, I have to square root, and we have to remember when you square root both sides, you get plus or minus the square root of negative x plus 4. Now we have the equations of both the actual equation and its inverse. Which looks easier to graph? The negative x squared plus 4 or the plus or minus square root of negative x plus 4? Probably go with the parabola, the negative x squared plus 4. So now, if we think of our transformations, we know what our parabola looks like. Does the negative outside make sense that it's a vertical reflection? It's going to make it go down. And the plus 4 is outside. That's going to shift it up 4 units. Okay? So as you do more and more graphing, it's my hope you would see this negative x squared plus 4. You could take your parabola, flip it, and move it up 4. And be able to graph that quickly. Again, I'd have to do some labeling here, so I'm going to label 0, 4, 1, 3, 2, 0, and may as well. There's 5 points on my graph. For graphing the inverse, I can try to use my transformations to graph this. But if you have one of them already, the easiest way is just to take your x and y coordinates and switch them. So I'll do that in purple. Like, what's going to happen is 0, 4, it's going to be 4, 0. 1, 3, 3, 1. 2, 0, 0, 2. And similarly, I would get these points as well. Now, as far as seeing the purple graph, okay, can you see that a sideways parabola is really just two square root graphs put together. And in fact, if we label each of these square root graphs, the top one, which I'm just going to color code the top one in orange. So the top square root graph there. Can you see that it was a regular square root graph, but there was a horizontal reflection? And then, after that horizontal reflection flipped over, it was moved 4 to the right. If I just write that out, y equals square root, horizontal reflection would be inside, 4 to the right, I'd have to write it in factored form. X's are liars, so 4 to the right would be x minus 4 like that. Can you see that our green equation that we found algebraically isn't in factored form? But if I factored out the negative, I would get that x minus 4. And the purple bottom part, also had a flip over the x-axis, also had a vertical reflection. So this one would be the negative square root of negative x minus 4. So we found it algebraically and we got the plus or minus. When we look at the graph, it now makes sense. Because the plus part is one square root graph, the minus part is another square root graph, and put together you get your sideways parabola. Is the inverse a function? No. Doesn't pass the vertical line test. There is an x value that has two y values, because that purple graph doesn't. The parabola, the green one, does, but the inverse does not. Okay, questions to circle on this one are 5 and 6. And actually, I'm going to add a little note for you here. I think actually there's a nice part in your notes. We'll do it right in your notes. So if we go whoa. I'm in the wrong. No, this is right. Yeah, this is where I want to go. So at the bottom of page 239, it says, when is the inverse of a function also a function? So we just did the parabola, and the inverse wasn't a function. We did that first example, and the inverse wasn't a function. Okay? Is there a shortcut to tell whether a function and its inverse will both be functions? And there is. If the original function y equals f of x passes the horizontal line test, then the inverse will also be a function. Makes sense? A parabola does not pass a horizontal line test. Gets hit twice. Inverse is not a function. A straight line passes the horizontal line test, so its inverse will always be a function.